The purpose of this primer is to quickly get developers up to speed with the primary persistence mechanism used in the 3 Weeks technology stack. Google Cloud Datastore is a distributed, highly available, key-value storage engine which we use extensively on Google App Engine. It's our go-to persistence solution for the vast majority of projects. Datastore is different from an RDBMS in a number of important ways. The first is that schemas aren't enforced, and entities can have any number of properties. Even amongst the same type, they don't need to share the same properties. The second is sequential auto-incrementing IDs are not supported. Third, there are no joins. Fourth, you may only query on defined indexes, which means no more table scans. And fifth, queries are weakly consistent. In the simplest terms, you can think of Datastore like a giant hash map. So how do we use it? Well, let's start with entities, which form our domain model. You can think of entities a bit like tables in that they define a type of information which can have any number of properties. So you can declare one like this. Note I'm using Objectify annotations here. Objectify is a high-level open source library recommended by Google for working with Datastore in Java. The Objectify docs are fantastic, and I highly recommend that you check them out over on GitHub once you're up to speed with the basics covered here. Coming back to our entity, we can't persist it yet. Each entity must define an ID which forms part of its key. IDs can be primitive longs, like this. They can be reference type longs, so big L longs, or they can be strings. Reference type longs, so big L longs, if left null, will be auto-generated. For all other types, Objectify expects that you would actually explicitly set the ID. So let's make our ID here. We need the ID annotation. Choosing a suitable ID is important. Like an RDBMS, IDs needn't be globally unique, but they must be unique to the entity type. So in this case, user. Unlike an RDBMS, there are no inserts, only puts, so be careful that you choose something guaranteed to be unique, otherwise you can unwittingly overwrite an existing entity, and the Datastore won't complain. Natural keys such as email addresses can seem like a good choice at first, but this can cause real problems down the line. Consider, for example, what happens if the user wishes to change their email address? Simply updating the ID field would create a new entity resulting in a duplicate record. You might be thinking, that's not so bad, I'll just delete the old one, which is fine, except that any other entities that hold a reference to the old entity's ID will now be invalid. To resolve this, we need to write a data migration, and that can be painful depending on the number of relationships and affected entities. In short, we recommend you choose something like a UUID, which for all practical purposes is guaranteed to be unique for your entity type. So let's see what that looks like. Note that what you call the ID field actually doesn't matter, it's just the annotation that specifies it's an ID. So now we're going to make a constructor. We'll make sure it sets the email and also initialize our ID. Just import that there. You'll notice that in adding the ID field, the email field now lacks any kind of annotation. Objectify will persist all fields of an entity unless they're static, final, or marked with the ignore annotation, like so. But let's not do that. While we're talking about fields, we should also quickly add some getters and setters, so we can actually access the fields. Now typically we remove the set ID since we really shouldn't be changing the ID after the object's created, so we'll just make that read only. Our entity is almost done, though it's missing something really important, a default or no-arg constructor. Objectify needs this and will throw an exception the moment you attempt to query the data store if you don't have one. So given that part of the contract of our object is that an email address needs to be supplied and the ID needs to be initialized, we make this private. The no-ID constructor can be any access level. It doesn't matter. But seeing as we don't want people creating partially initialized objects, we're just going to make it private. So I'll just make a note here that it's for Objectify so that people don't delete it. The final thing to think about is overriding the default equals and hashcode methods. Beside being good practice, one reason to do this is that entity classes will behave the way you expect when used inside collections such as sets and maps. It also has the benefit of making comparison easier when unit testing. A common solution employed here is to use the Apache Commons Lang reflections equals builder. So we'll just show that here. This seems like a good idea, and it can be a good choice for value objects such as DTOs, but it's a poor fit for persisted entities. Persisted entities must be considered equal if they share an ID. Anything else can lead to data loss because of the propensity for the data store to overwrite anything that shares the same ID. As I mentioned earlier, as far as the data store is concerned, they are the same thing even if their fields differ. The behavior of equals should reflect that fact. So it's really easy to do this. We'll just use the standard builder here and just include the ID, so no other fields. And there is our entity, ready to be persisted.